Now the condition del f equal lambda del g. Well, del f is fx times I plus fy times j. Del g is gx times I plus gy times j. So that del f equals lambda del g just means that, well, lambda times this equals this, means lambda times gx has to equal fx, and lambda times gy has to equal fy. Now that's two equations. How many unknowns do we have? You might think, well, we've got two unknowns, x and y. So we've got to solve for x and y, and we're going to get an x naught, y naught. Well, no, actually we've got three unknowns because we don't know what lambda is. So our third unknown, we need a third equation, but of course we've got one. It just might be a little hard to see because we've been assuming it for so long. But the other condition is we have to lie on the curve g of x, y. There might be a lot of points throughout space where del g equals del f, but only some of them lie on the curve g of x, y equals 0. So now we have three equations in x, y, and lambda. We solve those three equations, and now we have our critical points along the curve, and we can test them to see if they happen to be maximum or minimum. So here's our test. Here is the Lagrange method. It's just these three equations. But of course, remembering to write down these three equations and solve them doesn't mean that you understand what they mean. It means you can get the right answer if you happen to have a question that says use Lagrange multipliers to find this. Okay, it doesn't mean that you're going to understand the relationships of these gradients and the behavior of these functions in a way that would lead you to think of doing this. And it doesn't mean that you have the attendant understanding of the behavior of all these quantities and these characteristics of functions so that you can do other things with them as well. So, very important, I think, to understand all of this and understand where this comes from and understand what it's telling you about what's going on in the situation.